Hello guys. Yeah, welcome to NEET World. So in today's session now we are going to see the next part of the laws of motion. So yesterday we have completed up to the topic, up to this question we have completed, and the next part of the topic, Lam's theorem. Okay. So Lam's theorem states that if a body is in equilibrium under the acting of the three coplanar concurrent force, then each force is proportional to the sine of an angle between the other two forces. See, for example, if I take, if I consider this is tension T1 and this is tension T2 and this is tension T3, okay. If I want to find the tensions now, I can use this Lam's theorem, like T1. What is the opposite angle of T1? It is alpha, right? Then sine alpha, which is equals to T2. T2 opposite angle is sine beta, that is beta, no, sine beta. Similarly for T3, which is nothing but gamma, that is sine gamma. So this is about the Lam's theorem. When it is in equilibrium condition, I can use this, okay. So let me take a question on this and we will solve this. Yeah, here is the question. A block of mass 10 kg is suspended by the three strings as shown in the given figure. Then the tension, this is tension, no, yeah, tension T2 is asking. They are asking about the tension T2. I need to find what is the tension here. So could you find here by using Lam's? I will write the formulas also here. This is T1 by, I will consider this angle is alpha, beta and gamma, okay. Do it. Sine alpha is equals to T2 is equals to sine gamma, right? Yeah, sine gamma is equals to T3 is equals to sine beta. Okay. So let me solve this question. See here. So if I take the horizontal line, no, here horizontal line. So first thing, 60 30, it is 120, no, 60 30 is 90. So remaining angle is 90. Like sum of all angle is equals to 180 degree for the triangle. So remaining will be, this is 90 degree, okay. And then what about this angle? I will write this one. This is 90, right? This is 90 and this is also 90. If this one is 60 and opposite also will be 60 and this one is 30, this one will be 30, right? Now I can say that by this diagram, this is 90 degree and this one 60 plus 90 is 150 degree, right? This is T2 and this is T3 and this is T1 and this one will be 90 plus 30 is 120 degree. Now I can write it, the angles. T1 by sine 90, no, sine 90 is equals to T2 by, what is that, sine 120, no, sine 120 is equals to, what is T3? 150, right? T3 is equals to 150, sine 150. Am I correct? Yeah. Now I need to find T2, no? Either I can take these two equations or these two equations, T1 and T2 or T2 and T3. But I know, like here they have given that 10 kg and T1, no? So T1 is there, this is the point mass, T1 is upward and mg is downward, no, 10 into 10 which is nothing but 100, no, yes or no, 10 kg, the gravity is acting towards down, that is 10, so T is equals to 100 Newton, that is T1, I know T1, so I can use these two equations, no, T1 and T2. Now I can say that T1 by sin 90 is 1 which is equals to T2 by sin 120 is nothing but sin 90 plus 30, no, sin 90 plus 30, and I have gave the trick to find what is the sin 90 plus angle, no, if 90 is there I should change sin to cos, first thing, see 90 and 270 is there, I need to change that, if 180 and 360 is there, sin should be sin only, but for these cases sin will be changed to cos, cos will be changed to sin and tan will be changed to cot, okay. So T2 by cos 30, no, cos 30, one, then I should see that either it is plus or minus, so if I see 90 plus theta, no, 90 plus theta, so all silver teacup, so sin is positive in the second quadrant, so positive only, so this is 100, no, 100, and then T2 will be equals to 100 into cos 30 root 3 by 2 which is nothing but 50 root 3 is the tension at T2. Okay. If they are asking what is the tension at T3, again I can use this T1 and T3 equation and I can find it. So I can give the answer for the T3. So what will be the equation here? So T1 by sin 90 is equals to T3 by sin 180 minus 30 I can write, no, 180 minus 30, yes or no, yeah, so 180 minus 30 means there is 180, no, minus 30, it's negative, positive, right, yeah, so like sin and this is all trigonometric, so both are positive only, so I can write positive, and then 180, no, I can write same 90 only, right, I mean 180, no, same sign only I can write it here. So T1 by 1 is equals to sin 91, no, so T3 by this is same sign only and this is 30, this is about for T3. So I can write, no, 100 into sin 30, that is 1 by 2, so 50 Newton, yeah. So I can find the tension whatever asked like this kind of question, I can use the Lam's theorem. So next, okay, there is a question, a force of 50 Newton acts in the direction as shown in the given figure. The block of a mass 5 kg is at rest on a smooth horizontal surface, find out the acceleration of the block. Okay, here force is acting with some angle with respect to vertical, no, it's not horizontal, with respect to vertical it's acting 60 degree, so force is applied in the some angle, I need to take the vector components and then I should find the answer for this. First thing, this one will be my sin, no, sin 60, yes, sin 60, this is cos 60, no, this is cos 60, cos 60. So force is nothing but F is equals to ma, right, F is equals to mass into acceleration. So force is given that 50 sin 60 is equals to, what is the mass of the block, it is 5 kg, acceleration I need to find. So sin 60 is nothing but root 3 by 2, so 50 into root 3 by 2 divide by 5 which is nothing but a, so this is 25 and 1 sir, this is 5 sir, so acceleration is nothing but 5 root 3 meter per second square, this is the acceleration for the given question. See, why I am not considering this acceleration? If I consider this, I mean this force, the body won't move, like it's not acceleration, this force, no. If I consider this 50 cos 60, 50 cos 60 which is nothing but 50 into 1 by 2, no, 1 by 2 which is nothing but 25 Newton. So if I consider this 25 Newton on this body, body will not move. It will be on the same position only. I am applying a force like this, vertical force. Yes. Next question. Okay, we will see before that a motion of a connected bodies. See, let me take a bodies like three bodies, which is M1 and this is M2 and this is M3, where it's on the surface. If I apply a force here, F, so obviously body will move in this direction, no, right side direction. So acceleration will be in this direction, I will mention. Now what are the forces are acting in between? Contact forces are there. If contact force is there, normal will be there. So let me take this M1 as a point mass. Force is in this direction, right? F. So there will be a normal force in this direction as well as in this direction, equal and opposite. So one is N here. So acceleration is in this direction, no? This is A. For mass 2, this is, I will take point mass M2. So here N is there. I will take different color here. So here this is N and this will be N again. So this is N. F won't come here, no. F is acting on only this body, but object is moving. But if I see here, no, one more normal force is there for M2 and M3. This is N1 and this is N2. N1 only, same. So N1 and N1. Okay. So what I can say, this is N and this is N1. So acceleration is in this direction. Now what about M3? Only one force is acting, no? Only one force is acting. So only N1 is acting, no? N1. So no, there is no opposite direction, no, nothing is acting, opposing, right? So acceleration is in this direction. Now if I write the equation, so first thing, acceleration is in this direction, so first force I should write as F. So opposite direction is negative N is equals to M1A. This is the equation for the first one. Second one, this is N minus N1 is equals to M2A, right? For third one is N1 is equals to, this is M3, right? M3A. These are the equations I got from the three bodies when I apply force on body M1. Now if I add, this is equation number 1 and this is equation number 2 and this is equation number 3. If I add these equations, F minus N is equals to M1A. Then N minus N1 is equals to M2A, then N1 is equals to M3A. These are three equations, no? If I add these three equations, what I will get? Adding everything. So N1 and N1 cancel, N and N cancel, F is equals to M1A plus M2A plus M3A, which is nothing but M1 plus M2 plus M3 of A. So I need to find acceleration, means A is nothing but the force applied on a body divided by the sum of the all masses. This is the acceleration for the given. Okay. If they are asking about force, I can directly find the force. If they are asking about acceleration, I can find the acceleration by the given equations. Okay. Yes. Let me see a problem on this. Okay. So three blocks A, B, C of masses 4 kg, 2 kg and 1 kg respectively are contact on a frictionless surface. So surface is frictionless, first thing. As shown in the given figure, if a force 14 Newton is applied on a 4 kg block, 4 kg block is block A, right? Then the contact force between A and B. So there is a contact force between A and B, no? Like this is the contact, no? Surface contact. This is the surface and this is the contact between the A and B. I need to find that one. Same similar method only, right? So if I apply a force like this, there will be a normal here. One is in this direction and one is in this direction. Similarly, here also a normal is there. N1 and N2. I mean, sorry, N1 only, same N1 and N1, right? So first thing I need to find the force, right? So can I find the acceleration by using the previous equation? A is nothing but the force, total force, the given force by total mass, no, m1 plus m2 plus m3, which is nothing but force is 14 Newton, no, 14 by 4 plus 2, 6 plus 7,
2 meters per
which is nothing but 2 meter per second square. Okay. Now the equations can I write now here? So this is F minus, I will write it, point mass. This is M. Mass A, no? Okay. A, body A I will write. Body A, which is force is applied like this, and this is normal force. Acceleration will be in this direction only. Next one is B. So this is N1 and this is also N1, right? Yes, N1. So this is N. Okay, this is N. This is the direction of the acceleration. So I can write now F minus N is equals to mass of the object A into acceleration. So F is nothing but 14 minus N is equals to mass is 4 and acceleration is 2. So if I take this N this side and this 8 this side, no, 14 minus 8 is equals to N. So where N is equals to 6 Newton. Okay. Okay, I will write only 6 here. N is equals to 6. If I want to find what is the force between B and C, I need to find N1. That's it. You can find the force between C and B and C and give answer in the comment boxes, guys. And we'll go for the next. Yes. Okay. Completed, right? We'll go for the next. Okay. In this given figure, find the tension between M1 and M2, M3 and M2 and M3. So if I see the two strings, no, these two strings, is tension is same? No, right? No, because a block is in between them. If I consider a string like this, okay, tension will be same. But if I keep some block in between them, tension will be changed. Okay, let me find out that. So force is applied in this direction. Let me consider this is tension, opposite, away from the body. This is also tension T. So let me take this one as T1 and this one as T1. So point mass M3, this is F and this is T. So F is applied in this direction, obviously acceleration also in this direction. Next, yeah, next one is M2, right? M2 will be, T will be in this direction and T1 is in this direction. Acceleration also in this direction only, in the direction of T. What about M1? M1 is only T1 is acting, T1 is acting. There is no other forces. So this is the direction. Now equation for M3. What is F minus T is equals to M3A. What about this one? T minus T1 is equals to M2A. And what about this one? T1 is equals to M1A. So if I add these three equations, equation 1, equation 2 and equation 3.
F is equals to M1 plus M2.
So F minus T is equals to M3A, then T minus T1 is equals to M2A and T1 is equals to M1A. If I add everything, T and T cancel, T1 and T1 cancel. So I am adding here. So F is equals to M1 plus M2 plus M3 of A. So where the previous cases every block was attached together, in that case force was acting, that is normal force. But in this case no, this string is acting or a rope is acting. So only tension here, the normal force, that is the difference. So same here also, A is equals to F by M1 plus M2 plus M3. Yeah, we'll go for the next one. Yeah, so there is a at machine is there. Find the acceleration of a block and tension in the string. So consider m2 is greater than m1. Okay, consider this is the case. Okay, now what I can see here, a same string is acting for m1 and m2. Then what is the thing we can observe? The same tension is not changing. If here T, here also T only. So I can write now this is T and this is also T away from the body, right? So now I can say that this is m2G and this one will be my m1G, right? So if I consider m2 is greater than m1, obviously the block will be going in this direction. For m2 it is going downward, for m1 is going upward. So if I see here, no, this case I will write here m2 point mass is there, this is my m2G and this is my tension. So acceleration is going in this direction. So where acceleration is acting, write first that force m2G. Opposite to that acceleration, write in minus T is equals to m2A. This is equation 1. Similarly for this m1 also, if I write m1, this is my m1G and this is my tension. So in this direction it is going, in the direction of tension. Now what I can say, T minus m1G is equals to m1A, which is equation number 2. Okay. Now from this I can find the acceleration, no? So if I add both the equation, what I will get? Add both the equation, T and T will get cancelled. So m2 minus m1 of G is equals to m1 plus m2 of A. So where A is nothing but m2 minus m1 by of G, m2 minus m1 of G by m1 plus m2. This is the acceleration formula. If I want the tension, no, take the acceleration formula and substitute in equation 1 or 2, you will get the tension. Take this acceleration, substitute here, you will get the tension. You can find the tension here, or in this formula also I can use it. Okay. So let me give an example here in this question itself. Suppose consider that m2 is equals to 5 kg and m1 is equals to 3 kg. Find the tension and the acceleration. This is the case. Find the tension and the acceleration for the given case. m2 is 3 kg, m2 is 5 kg and m1 is 3 kg. So obviously acceleration will be in this direction for m2, for m1 it is upward direction. So give the answer for this question, guys.
2.5 meters.
Find the tension also, both acceleration and tension. So I need to find acceleration as well as tension for the given question. So you can give the answer in the comment boxes, guys. So we can clarify what is the answer it's coming. We can cross verify. So can we start? This is my m2G and this is my tension, and this is my m1G and this is my tension. So for that equation, no, for this case m2G minus T is equals to m2A. For this m1, T minus m1G is equals to m1A. If I add both of them, T and T get cancelled. So here m2 minus m1 of G by m1 plus m2 is equals to A. So what is m2 here? 5 kg. So 5 minus 3 divided by into 10, no, this is 10. We will consider G as 10, okay. So this is 5 plus 3 equals to A. So this is 20 by 8. 20 by 8. So 5 and this is, so this is 10, no, 10 and this is 4 and this is 2 and this is 5. So 2.5. So acceleration is 2.5 meter per second square. So I can take this acceleration and substitute either 1 or 2, equation number 1 or 2. So let me take the equation 1 where m2 is nothing but 5 into 10 minus t is equals to, this is m2, 5 into 2.5, no? 2.5. So take 50, this is 5, 2.5 into 5, how much? Is equals to t, 12.5. So 25 into 5 is 125, 1 point is there, 12.5. So tension is 37.5 Newton. This is the tension. So if you take this acceleration and substitute the acceleration in equation 2, you will get the same tension. Okay. Okay, here is another question. Two masses m1 is equal to 5 kg, m2 is equal to 10 kg are connected at the ends of an inextensible string passing over a frictionless pulley as, okay, I will give you the figure. Okay, I will give you the figure. When masses are released, the acceleration of the mass will be, okay. So in these cases, we are drawing the figure. Here is a frictionless pulley is there where a mass, what is the mass? 5 kg is connected as well as 10 kg is connected. This is 5 kg and this is 10 kg. I need to find the acceleration of the masses. Okay. So what will be the acceleration for 5 kg? It is downward or upward? So when I compare with another masses, it is less than the another mass. So it will be upward and this one will be downward. This is A and this is A. So tension. So now I can find, no, easily. I can say that A is nothing but m2 minus m1 of G by m1 plus m2. So whenever you are getting these kind of question, no, directly you can use this formula. Okay. So what is m2 here? 10 minus 5 into 10 divided by 10 plus 5, which is nothing but 5 into 10 is 50, 5 plus, so 10 plus 5 is 15. So 3 sir and this is 10 sir, which is nothing but 3.667. So 3.6 meter per second square is the answer. 3.33. Yeah, 3.33. So 3.337, 334, yeah, 3.334 meter per second square. So 10 divided by 3, no, 9 and remaining is 1, again point, fine. Next question, completed, no? Yes. We'll go for the next question. So the next question is, a person of a mass 60 kg is inside a lift and a mass of 940 kg, like lift mass is 940 kg and person mass is 60 kg is given, and presses the button on the control panel, the lift starts moving upward direction, okay, and the acceleration is 1 meter per second square. If G is 10 meter per second square, the tension supporting cable, see, if I see the lift, no, obviously there will be a cable, right, to lift it or to pull it down. So this is my tension. So what is the lift mass? 940 plus 940 plus 60. So 1000 kg. So obviously this is my 1000 into G, right? 1000 G, I'll write it. Okay. So in which direction lift is moving? It is upward direction, no? So acceleration is upward. So what will be the equation? In the acceleration direction, what is the force? T. So opposite direction, 1000 G. 1000 G is equals to mass, that is 1000 into A. Okay. Now I need to find the tension, right? Yeah. So T minus this is 10,000, right, is equals to again 1 meter per second, right, 1000. So T will be equals to 1000 plus 10,000, which is nothing but 11,000 Newton. This is the answer. Okay. Next question is there. The mass of a lift is 2000 kg when the tension in the supporting cable is 28000. That's 28,000 Newton. Then its acceleration is, okay. So previous case acceleration is given, I need to find the tension, but in this case tension is given, I need to find the acceleration. You can take the question and give answer in the comment boxes, guys. Take as a homework question. Take the question. We'll go for the next question. Yes. See here. In this question, okay. In the arrangement shown, all the surfaces are smooth. String and pulley are light. Okay. There is no mass for the string and pulleys. Okay. There is no mass. It's a massless. Find the tension in the string. What I can do here? First thing I need to write down the weight, that is 2g, right. Now the angle is acting, no, I said no in last class. So whenever angle is acting like this, take 8 divisions like this. This is my 37 degree. So this is my again 37 degree, no, theta, and this is theta. So downward it is 2g, right, and this one will be my 2g cos theta, and this is my 2g sin theta. So now I can write it, no, 2g cos theta. So in this case it is 2g sin theta. Similarly for this also I need to write it. I'll take another color here. Okay. So what is this one? This is my 2g again, but the angle is 53. So I'll write the angle also here, 37 degree, and this is 37 degree. Okay. Now this is my, see, this is angle, no, this is the angle. Okay. Take this triangle and keep like this. Okay. If I keep angle here, again theta will be here. Okay, theta will be here. I'll write it here. Yeah, for this case angle is given like this, theta. So this is theta, and this is theta, right. So this one will be my mg cos theta, and this is my which one in this case, no, this mg, and this is my mg sin theta, right, mg sin theta, cos theta and sin theta. Okay, now I can say, no, this is 2g sin 53 degree. Okay, sin 53 degree. Now if I see the cable, no, for this mass and this mass same cable is used, so tension will not be changed. This is T and this is also T. Okay, now I need to find it. Why? Like I need to find the acceleration, which direction? No, simple thing, take this one and this one, 2 into g, that is 10 sin 37 sin 53 I need to find. So take a triangle like this. I have said, no, this is 53 and this is 37 and this is 90. So 5 is there, keep in hypotenuse, 3 in the opposite direction and remaining 4. So 3, 4, 5 triangle. Okay, the triangle number 3, 4, 5 gives the angle 53 and 37. So what is this sin 37? No, sin 37 is opposite by hypotenuse, which is nothing but 3 by 5. So 1s are this is twice. So 2 into 2, 4, 4 2s are, so 4 3s are, this is 12. Okay, this force is 12 Newton. What about this force again? 2 into 10 sin 53, right, opposite by hypotenuse. So into 4 by 5, this is 1 and this is twice, 2 2s are 4, 4 4s are 16. So this is 16 Newton. Now I can say no, this is 12 Newton and this is 16 Newton. So acceleration is obviously in this direction. This is my acceleration for this direction. Okay. Now I can find the equation, I can find the tension in the cable. You can give tension answer as take as a homework, and one more question will give. This is the question, this also take as a homework question. Okay guys, so with this we will complete this class. We will meet tomorrow. Thank you guys, bye bye.